Hello everyone. So now we will study about shunt clipper circuit. So here output and diode will be connected in parallel. In series clipper circuit, output and diode were in series. Okay. So first we will study positive shunt clipper circuit. Why is it called positive? Because positive part will be clipped off. So let's see the analysis of very simple circuit. So here the diode is given. What we will do? We will apply open circuit test. So this is the diode that is given. Diode that is given. Now since we are going to apply open circuit test, so what will happen? This diode will be open circuited, so there will be no current through the resistor. If there is no current through the resistor, that means this V in will come here, right? We are going to apply open circuit test, so that means this diode will be open circuited. So if open circuited, that means there will be no current through the resistor. So V in will come here, and this is grounded, so 0 will be here. Okay, and what you can see, this is P, this is N. So first condition, when Vin is greater than 0, that means diode will be on. Now tell me what will happen if diode is on. So this is the condition. If diode is on, diode will be shorted. So this will be shorted. This is resistance R. This is Vin applied here, and this is our V naught. So tell me what is the value of V naught? V naught is 0 only because this is shorted. So V naught will be 0 volt. In the second condition, when Vin is less than 0, what will happen? Diode will be off. If diode is off, that means diode will be open circuited. So tell me what will be the condition? This is V in. If diode is off, this will be your V naught. If diode is off, there will be no current through the resistor, so complete V in will be reaching to V out. So V out will be equals to V in. So what do you see here? For V in less than 0, V out is equals to V in, and for V in greater than 0, V out is 0. Right? So we can draw the graph now. Graph will be between V out and V in. For V in greater than 0, V naught will be 0. For V in greater than 0, V naught is 0. And for V in less than 0, V naught is equals to V in. So here V naught is equals to V in. This is V naught is equals to V in with slope being 1. Okay, let's see it in the graph. So for values greater than 0, it will be 0. And for values less than 0, it will be the same. So this is our shunt clipper circuit. Well and good, very easy. For V in less than 0, for positive values, for all these values, it will be 0. For negative values, it will follow the input. All the positive values, it is 0. For negative values, it will follow the input. Then it will be 0. Okay, let's move on to the next problem. Here you have to draw the transfer characteristics, but diode has the cut-in voltage. How to solve the problem that diode has cut-in voltage? Just take the battery out of the diode, right? So I will take the battery out of the diode. So you can either take the battery here or before it, because battery and diode will be in series. So better I will take it before the diode, or you can take it after the diode as well. Anywhere you can take. So this will be our condition. This will be 0 volt. This end N is connected to 0 volt grounded, and here we are having V in. Since why V in? Because we are applying open circuit test, right? We are applying open circuit test. So this will be our P, this will be our N. This is our P and this is our N. Okay, and we are taking the battery out of the diode, that means this will be 0.7. So P potential will be V in minus 0.7 and N will be at 0. So first thing, when V in is greater than 0.7, or you can say V in minus 0.7 is greater than 0, or you can say when V in is greater than 0.7, at that time what will happen? diode will be on. Now if diode is on, what will happen? What will be the value of output? If diode is on, so here you are having V in. This is resistance R. If diode is on, what will happen? This will be replaced with the battery. Diode will be replaced with the battery of 0.7 volt. So it is replaced with the battery of 0.7 volt. And this is your V naught. So V naught will simply be 0.7 volt, right? And secondly, if V in is less than 0.7, what will happen? Diode will be off. Diode will be off, that means it will be open circuited. And if it is open circuited, that means complete V in will be going to V out. If diode is off, it will be open circuited, complete V in will be going to V out. So V out will be equals to V in. Right? So let's draw the graph now. V out versus V in. What do we call it? Voltage transfer characteristics. What is the what point did we call it? Transition point. So what is the transition point? At V in equals to 0.7 something happening. So for V in greater than 0.7, it is always, one second, I need to change the color. Yeah. So for V in greater than 0.7, it is always equals to 0.7. It is always equals to 0.7 volt. For V in less than 0.7, V out is equals to V in. So for V in less than 0.7, V out is equals to V in. So here your V out is equals to V in, with slope being 1. Well and good. Let's move on to the next problem. Now we will study negative shunt clipper circuit. Okay. So in this, what will happen? Negative part will be clipped off, only positive part will remain. As you can see the circuit, you can try doing the analysis on your own. Okay. So what we will do? We will apply open circuit test. Open circuit test. Now some student will get a doubt that, sir, how do you say that diode will be having V in voltage, right? They will have the doubt. So now we are applying open circuit test. So in open circuit test, resistance will have 0 voltage drop. Are you getting my point? You are applying open circuit test, so resistance will have 0 voltage drop. So that's why you can say that complete V in will be coming across the diode. Okay. And depending on the diode operation, whether it is on or off, you can define the voltage across the resistance. Are you getting my point? What is my point? People will have the doubt that how you can say that complete V in is going across the diode when there is a resistance connected. But we are applying open circuit test. In open circuit test, there is zero current, and the same zero current is flowing through the resistor as well. So zero current is flowing through the resistor. That means voltage is not having any voltage drop. Sorry, resistance is not having any voltage drop. So the complete V in is going across the output. Right? So we are applying open circuit test now. So what will happen? This is the N side, this is the P side. P side is at 0 volt. This is N, this is P, and this is V in. Okay, so first condition, when V in is greater than 0 volt, that means diode is off. And if diode is off, that means what will happen? Complete V in will be going to the output. So V out will be equals to V in. Right, diode is off, that means this is the condition. This is the resistance R, V in, this is V naught. So V out is equals to V in, right? And second condition, when V in is less than 0 volt, that means this potential is less than this potential. That means diode will be off. Sorry, diode will be on. And if the diode is on, that means V out will be equals to 0 volt. Why so? Because this will be the condition. Because diode is on, so this is the resistance R. If diode is on, this is V in, this is V naught. So V naught will be 0. Now let's write down the potential of VR as well. Let's call this as VR. Okay. So in this condition, what is VR? In this condition, VR is 0 volt. Because diode is off, there is no current. Simply V out is equals to V in. So in this condition, VR is 0 volt. Your VR is 0 volt. And in this condition, what is VR? In this condition, tell me what is VR? this is our VR, right? This is our VR. So here V naught is 0. V naught is 0. So this potential is 0 and this potential is V in. So here VR is equals to V in. Well and good. So in this condition, VR is equals to V in. And what about V naught? V naught is 0 volt for V in less than 0, and for V in greater than 0, it is V in. So we will make the graph for V naught versus V in. V in greater than 0 volt, it's equals to V in. V naught is equals to V in, and for V in less than 0 volt, V naught is equals to 0. Here this is V naught equals to V in. Okay, now you can draw the graph as well, right? In the similar manner. For V in greater than 0, it will be there, and for V in less than 0, all the values will go to 0. All these values will go to 0. All these values will go to 0. Well and good. Let's move on to the next problem. So here we will see positive shunt clipper circuit, but with a positive bias. So there a positive bias is given. Okay. So again apply the open circuit test. Again applying the open circuit test. Now tell me, this will be our P, this will be our N. At P you are having V in. Resistance will have 0 voltage drop because you are applying open circuit test. You are applying open circuit test. That means you are assuming the diode to be off, right? So you are assuming the diode to be off. That's why you are applying open circuit test. So here you show that here at P potential you are having V in, at N potential you are having VB, right? At N potential you are having VB because this potential is 0. This potential will be VB. So V in and VB. So first condition, when V in is greater than VB, what will happen? Diode will be on, right? When V in is greater than VB, diode will be on. So what do you think? What will happen now? What will be the output? If diode is on, diode will be shorted, but VB will remain there, right? And this is your V in, and this is your output. So V out will simply be equals to VB. V out will be equals to this battery only. V out will simply be equals to VB, right? Let's see the second condition, when V in is less than VB. When V in is less than VB, that means N potential is higher, diode will be off. Diode will be off. So tell me, what will be the value of output? This is V in. Here the diode will be off. This potential was VB there. So what will be the value of output? Tell me. This is your V out, right? So V out will simply be equals to V in only. Did you say output will be equals to V in minus VB? V out will be equals to V in minus VB or only V in? Output will be equals to V in only, right? Not V in minus VB. Why so? Because this is open circuited. Now there is 0 current through the resistance. This potential is 0. This potential is 0. And this potential is V in. 0 current through the resistance. So this potential will be V in. So now what is your output? Output you are collecting across the diode and the battery combined. Diode and the battery combined. So complete V out is equals to V in only. If they had asked you what is the potential of VD, if they had asked you this, in this case what is VD? VD is 0 in this case. Why so? Because diode is shorted. And in this case what is VD? In this case VD is V in minus VB. Are you getting my point? What is your V naught? V naught is this complete. This complete. So if diode is off, that means there is no current in the circuit. No current in the circuit, that means here 0 potential, here V in potential. So complete V in is going to the V out. So V out is equals to V in. But what is VD? VD is the potential across the diode. So here you are having V in, and at this potential you are having VB. So VD is V in minus VB. Got my point? Okay, so basic network analysis is there, but these basic concepts are not clear sometimes if you haven't studied network analysis properly. So I hope you have studied network analysis properly. If you have studied network analysis properly, this will be a cakewalk for you, right? So let's draw the graph now. So we will draw the graph. Transfer characteristic is always between V0 versus V in. Transfer characteristics is always between V0 and V in. So what is the cut-in point? Sorry, not cut-in point. What is the transition point? That is VB. So for V in greater than VB, V out is always equals to VB only. For V in greater than VB, V out is always equals to VB. And for less than that, V out is always equals to V in. Okay. So there you go. So this potential will be VB only. Well and good, very easy, very straightforward. Let's move on to, okay, before moving on to the next problem, we have to draw the graph as well. So how will the graph go? What is the cutting point? That is VB. Not cutting point, transition point I should say. That is VB. Okay, so for V in greater than VB, your output is always VB. For all these points, your output will always be VB. Let's assume this point is VB. So for V in less than VB, it will be like this. Then after that, it will be constant to VB only, right? To VB only. Then after that, it will go down it will be VB. Then again it will go down and it will go like this. Okay, so before it is following like that. Okay, because this was a positive shunt clipper circuit, right? Let's move on to the next circuit. Now you have to draw the transfer characteristics. So cut-in voltage is given. So for cut-in voltage, what I will do? I will take the battery out of the diode. Okay, so I can take the battery out of the diode here as well or here as well. So depending on you where you take the battery out of the diode, because battery will be in series only. So this is our diode. I am taking the battery out of the diode here this time. Okay, and this is my 1 volt already there, and this is ground. So basically this is 1 volt. I am taking the battery out of the diode 0.7 volt here, and this is my V in. So if this is V in, this will be 1.7 volt, right? 1 volt and 0.7 volt out of the battery. So 1.7 volt. So basically first thing, when V in is greater than 1.7 volt, at that time diode will be on. Tell me what will be the output value? No one should tell wrong. No one should tell the wrong answer. What will be the output value? It will be 1.7 volt, right? It will be 1.7 volt. Why so? Because diode will be on and it will simply be replaced with the battery of 0.7 volt. So this is the resistance R. Diode will be on. That means it will be 0.7 volt and 1 volt battery is already there. So this is 0.7 volt. This is 1 volt. This is V0 and this is V in. V0 is 1.7 volt, and secondly, when V in is less than 1.7 volt, what will happen? Diode will be off. Diode will be off. And if the diode is off, tell me what will be the output value? If diode is off, what will be the output value? 0 volt, right? sorry, output value will be equals to V in. V out will be equals to V in. Why so? Because what will be the circuit? Resistance R, diode is open circuited, but 1 volt battery will be there, but you are collecting the complete output. You are collecting the output here, right? So this is your complete output. So 0 V in, that will be equals to V out only. There is no current through the resistor R. So 0 and the upper potential will be V in, and the same potential will be going across the output as well. So V naught will simply be equals to V in only. And let's draw the graph. So for what is the cutting point? That is 1.7 volt. So for greater than that, it is always equals to 1.7 volt, and for less than that, V naught is always equals to V in. Okay. For V in greater than 1.7 volt, it is always equals to 1.7 volt, and for V in less than 1.7 volt, V out is equals to V in. That's it. Okay. Let's move on to the next. Positive shunt clipper circuit with the negative bias. Okay. So the bias is negative this time. So again, draw the diode. Tell me at this potential what you are having. At N side, what you are having? Minus VB, right? Because this is VB, this is 0, this will be minus VB. And at one potential, you are having V in if you are applying open circuit test. If you are applying open circuit test, right? Because in open circuit test, diode will be open circuited. So in open circuit test, diode will be open circuited. This will be your P side, this will be your N side. So first, V in is greater than minus VB. That means diode will be on. And if diode is on, that means V naught will be equals to minus VB. Now I don't need to make the graph, I guess, right? I don't need to make the graph because we have seen a lot of example now. Diode is shorted now, so simply this complete minus will be there, minus VB will be there across the V naught. And when V in is less than minus VB, at that time, what will happen? Diode will be off. And if the diode is off, what will happen? The complete V in will be coming across the output. So V out will be equals to V in. How will the graph go? Like that. Why it is B, by the way? Why I am writing B here? B for bias. Okay, that's why I am writing bias. Yeah, so V in is minus VB. So this is minus VB. So for V in greater than minus VB, it is always minus VB. For that much of time, it is always V out is always equals to minus VB. V out is always equals to minus VB. And for V in less than minus VB, V out is equals to V in. Here, V out is equals to V in. Well and good. Now you can draw this graph on your own. So what is the cutting point? That is minus VB. Cutting point is minus VB. So for V in greater than minus VB, it's always minus VB. So for all these points, it will always be minus VB, and less than that, it will follow the input. For every value greater than minus VB, it will always be equals to minus VB only. For every value greater than minus VB, for all these points, it will always be equals to minus VB. For all these points, it will always be equals to minus VB. right, equals to minus VB. And for less than that, V naught will be equals to V in. It will follow the input. This will be minus VB. Well and good. Okay, let's move on to the next circuit. Why I am moving so fast? Because we have seen so many circuits. I hope you are comfortable with those circuits now, right? All these circuits. You can once revise it on your own, but I guess you are comfortable now. That's why we are moving a bit fast. Now you have to draw the transfer characteristics with V gamma is given. That means cut-in voltage is given. So what you will do? Take the battery out of it. So you take the battery out of the diode. So this is the P terminal. And if we are applying open circuit test, then I can make it like this. The battery will be taken out of the diode. And this potential here, that will be grounded. This potential is 1 volt, this potential is 0.7 volt. So tell me at negative potential what you are having? 0 minus 1.7. So this potential will be minus 0.3 volt, right? 0 minus 1 plus 0.7. So this potential will be minus 0.3 volt. And since we are applying open circuit test, this will be open circuited. So first thing, when V in is, this is P, this is N, right? So there will be no current through the resistor. So V in complete will come here, and from diode 0.7 voltage will come out. So minus 1 plus 0.7, that means minus 0.3. Always solve the problem whenever there is cut-in voltage given. Always solve the problem by taking the battery out of the diode. That will be the easiest method, and you will never do the problem wrong. That's my guarantee. If you just keep on thinking that, okay, here minus 1 is there, so how much potential I can afford? Some people solve like that, how much potential I can afford because cut-in voltage is given like that. So in those problems, you will do the mistake of plus minus. Instead of that, always take the battery out of it and solve the problem. It will be very easy. So now just V in is greater than minus 0.3 volt. What will happen? Your diode will be turned on. And if diode is on, tell me what will be the output value? Diode is on, this will simply be shorted. So V out will simply be equals to minus 1 volt, right? Now I don't need to make the circuit because we have seen a lot of examples. Now secondly, when V in is less than minus 0.3 volt, tell me what will happen to diode? Diode will be off. And if diode is off, what will happen? Tell me. V out will simply be equals to V in, right? Why V out will simply be equals to V in? Because diode will be off and complete V in will be coming out of the, complete V in will be coming towards the V out, right? Diode is off, no current through the resistor. So V out will simply be equals to V in. So what was our transition point? Transition point is minus 0.3 volt. Minus 0.3 volt. So for greater than that, it is always equals to minus 1. Sorry. Okay. There is this mistake. What will be V out? Here, what will be V out? If diode is on, what will happen at the output? This diode will be replaced with the 0.7 volt battery, right? This will be replaced with the 0.7 volt battery, and here it will be 1 volt. Oh, sorry. This is 1 volt, and this will be a 0.7 volt battery, and this is your V naught. This is your V naught. So minus 1 plus 0.3, that will be minus 0.3 volt, right? And I did a blunder there, right? Diode will be on, it will be replaced with the 0.7 volt battery. So minus 1 plus 0.7, what will be that value? Minus 0.3, right? So when I was drawing the characteristics, voltage transfer characteristics, I got to know that there is some mistake. So that should be minus 0.3 volt. Are you getting my point? If diode is on, that will be replaced with the battery of 0.7 volt. So minus 1 plus 0.7, that means minus 0.3 volt. And for V in less than minus 0.3 volt, diode will be off. So V out will simply be equals to V in. Well and good. Let's move on to the next problem. Now we will see negative shunt caliper circuit with the positive bias. So these kind of circuit we will keep on studying. Let's solve the circuit. So here we will be applying open circuit test. So if we are applying open circuit test, this is your N potential, this is your P potential. At N potential you are having V in. At P potential what you are having? VB, right? Because this is 0, this will be VB. So at P potential you are having VB. So first, when V in is greater than VB, what will happen? Diode will be off. And if diode is off, what will be the answer? V out will simply be equals to V in. Right? No current through the resistor, so complete V in will be coming out to the output. So when V in is less than VB, what will happen? Diode will be on. And if diode is on, that means this diode will be shorted. So V out will simply be equals to VB. Well and good. Let's draw the transfer characteristics. What is the cut-in point? Cut-in point is VB. So for V in less than VB, V out is equals to VB. For V in less than VB, V out is equals to VB. And after that, for V in greater than VB, V out will always be equals to V in. This point is VB. So V out is always equals to V in. Okay. So what is the transition point? That is VB. Transition point is VB. So for every value greater than V in, for every value greater than VB, V out is equals to V in. So for every value greater than VB, for every value greater than VB, V out is equals to V in. So for less than that, it is always equals to 0. Not 0, it is equals to VB. For all the lesser value, it is equals to VB. And for all the greater ones, V out is equals to V in. For lesser ones, it's equal. For greater ones, okay, it will go on like this. So here V out is equals to V in, and this point is VB. Well and good. Let's move on to the next problem. So here cut-in voltage is given. You have to draw the transfer characteristics. What you will do? You will take the battery out of the diode. What you will do? You will apply open circuit test. This potential is V in. You will apply open circuit test. You will take the battery out of the diode. This is 1. This will be 0.7. Right? Positive and negative. Positive and negative, like that. And if you wanted to take it upward, negative, positive, negative, positive, right? So we are taking it this side. So this will be 0, this will be 1, this is 0.7, that means this will be 0.3 volt. And this is N, this is P. First thing, when V in is greater than 0.3 volt, that means diode will be off. And if diode is off, that means your V out will simply be equals to V in, right? Then let's see the second one. When V in is less than 0.3 volt. When V in is less than 0.3 volt, that means diode will be on. And if diode is on, tell me what will be the output voltage. So if diode is on, this will be replaced with a battery of 0.7 volt. So 1 minus 0.7, that means 0.3 volt, right? So that will be equals to 0.3 volt. Are you getting the point? Why it is 0.3 volt? Right? Or shall I make the circuit here? So the resistance and diode will be replaced with the battery of 0.7 volt, and there is 1 volt is already given. This is V in, this is a resistance R, this is 0.7 volt, this is 1 volt, and this is V naught. So 1 minus 0.7, that means it will be 0.3 volt. What is my cut-in point? Not cut-in point, transition point. So that is 0.3 volt. So this is 0.3 volt. So for V in greater than 0.3 volt, it is always equals to V in, and for V in less than 0.3 volt, V out is equals to 0.3 volt only. And after that, it is always equals to V in. Well and good. Here it is, V naught will be equals to V in. Okay, let's see the next circuit. You tried doing it on your own. So I hope you must have done it on your own. So we will do the open circuit test. So this point will be our N, this point will be our P. At N side we are having V in, at P side we are having minus VB. So let's take the first one. When V in is greater than minus VB, at that time what will happen? Diode will be off. And if diode is off, that means V out will simply be equals to V in. Right? Well and good. Secondly, when V in is less than minus VB, that means diode will be on. If diode is on, then diode will be shorted. V out will simply be equals to minus VB. Now you can just draw the transfer characteristics between V out and V in. What is our transition point? That is minus VB. So for greater than that, it is always equals to V in, and for less than that, it is always equals to minus VB. So for V in less than that, it is always equals to minus VB. It is always equals to minus VB, right? And for V in greater than minus VB, V out is equals to V in. Okay, V out is equals to V in. That's the transfer characteristics. Okay, you have to draw the sinusoid waveform as well. So yeah, you can do that. What is the transition point? That is minus VB. Transition point is minus VB. So we have seen every single possible example of single stage single stage clipper circuit. Okay, every possible example. For V in greater than minus VB, it is always V in. Okay, so for all these values, it will always be equals to V in. So for all these values, it will follow, and for lesser than that, it will simply be that one value. Like this, right? And this value will be minus VB. Well and good. I hope you are understanding everything along with me. And if you are doing in the rough notebook something along with this, you should be doing in the rough notebook. Notes I am giving, but you should be writing something in your rough notebook at least, right? So then only the lecture will be interesting. If you are just watching the lecture without even doing anything in your notebook, you will just find it boring, because it's like watching the web series, right? But this is not web series. This is a lecture, right? So do this on your own now. This one you have to draw the transfer characteristics. Do it in your rough notebook. Okay, so let's solve it now. What I will do, I will take the battery out of the diode. Okay, so I am applying open circuit test only. but I am taking the battery of the diode in this manner. This will be 1 volt, this will be 0.7, this is P, this is N, this is V in. At P side you are having minus 1.7 volt. Okay, so the first one, if V in is greater than minus 1.7 volt, then what will happen? Diode will be off, and if diode is off, V out will simply be equals to V in, right? And secondly, if V in is less than minus 1.7, that means diode will be on, and if diode is on, that means it will be replaced with the battery of it will be replaced with the battery of 0.7 like this. So output will be minus 1 minus 0.7, that means minus 1.7 volt, right? I hope you understood. Output will be minus 1.7 volt. Did you understand it? You can draw the circuit on your own, then you will understand for sure. Okay, diode will be replaced with the battery of 0.7 volt. So 0 minus 1 minus 0.7. V out will simply be equals to minus 1.7 volt. So what is the cut-in point? That is minus 1.7 volt. Okay, so for V in greater than minus 1.7 volt is same. For V in less than minus 1.7, it is equals to V out is equals to minus 1.7 only. For V in less than minus 1.7, it is equals to minus 1.7 only. And for V in greater than 1.7, V out is equals to V in. V in. Well and good. So we are done with the shunt clipper circuit. All the possible example, every single possible example we have seen. There can be no more example after this. Although in the next circuit we will see that what we will see. We will see the assignment problems as well. Those will be very good problems. So we are done with the single stage clipper circuit. Now I will talk about two stage clipper circuit. So what is the difference between single stage and two stage? Like see the transfer characteristics. Here what do you see? Only one transition point is there, right? All the transfer characteristics you could see only one transition point, but in the double stage you will see two transition points. Okay, so let's see the example. You have to draw the voltage transfer characteristic and find the maximum and minimum value of V naught. Okay, so for now try doing it on your own. This is the resistance R is there. Okay, V in R is there, then diode, this is the thing. Okay, for now try doing it on your own. So what we will do, we will simply apply open circuit test. So applying open circuit test, the best thing is apply open circuit test. Whenever there is a voltage given, always try applying open circuit test. And when there are current given, always try applying short circuit test. Right? So this we have already seen in the basics. Diode D2 will also be open circuited. This will be your V naught. And this is your V in. This is 4 volt. This is also 4 volt. If this potential is 0, this will be V in. And this side is N, this side is P, this side is P, this side is N. In the exam, you will not need to draw it like this, right? In the exam, you will be able to see it properly. Like, okay, this V in will come. So if V in is greater than 4 volt, diode D2 will be on. But here I am explaining, that's why I am making it like this. Okay, open circuit test we are applying. So this is open circuited, this is also open circuited. So there is no current through the resistor. So complete V in will be going towards like that. Okay, so 0 voltage is there. So this potential is 0. This potential will be V in. This also V in. This is also V in. So here you can see one thing, that is, first is, if V in is greater than 4 volt, what will happen? Diode D2 is on and diode D2 is off. Because if V in is greater than 4 volt, that means N potential is higher than 4 volt. P is already at minus 4. P is already at minus 4. And this is higher than 4 volt, more in positive. Are you able to understand? This is already at minus 4. Now this is greater than 4 volt, somewhat 4.1. So what you are having? P at minus 4 and N at minus N at 4.1. So minus 8.1. From P to N you are having minus 8.1. That means diode is off. Diode is D2 is on and D1 is off. So what is happening? D1 is off, D2 is on. So what will be your circuit? Resistance R. This will be open circuited. There will be this battery involved. This is V in. Diode is on. If this diode is on, and this will be a 4 volt. That will be equals to V naught. So simply this diode is on. So V naught will simply be equals to 4 volt. From here you can see V naught is simply equals to 4 volt. Right? Well and good. Now see one more condition. How to turn on this diode? When V in is less than minus 4 volt. V in is less than minus 4 volt. When V in is less than minus 4 volt. Look, this is the diode. This is at minus 4. If this is less than minus 4 volt, that means this potential will be less, N potential will be less, P potential will be more. So at that time, the diode D1 will be on, diode D1 on, and D2 will be off. Why D2 will be off? Check it on your own. At P potential you are having 4 volt. At N potential you are having 4 volt. At N you are having 4 volt. And you are at P you are having negative minus 4.1. Less than minus 4 means less than minus 4 means minus 4.1. So what is the potential you are having from P to N? From P to N, minus 4.1, minus 4, minus 8.1. That means diode will certainly be off. Right? So diode is D2 is on and D2 is off. So what will be the output? If this is off, this will not come. There will be no use of this battery. If diode D2 is off, there will be no use of this battery because there will be no current in this battery. And this D1 will be shorted. If D1 is shorted, that means complete minus 4 will be going towards the output. Right? So this D1 is shorted, then complete minus 4 will be going towards the output. So Vout will simply be equals to minus 4 volt. So this is the second case. Now we will check for minus 4 to 4, in between minus 4 to 4. So the third case we will check is V in is minus 4 to 4. Not equal, we can put there. V in is minus 4 to 4. Okay, here you can put equal. So now V in is minus 4 to 4. Any value, you can take any value. Let's take 2. Let's take 2. When V in is equals to 2 volt. You will put 2 here, 2 volt here and 2 volt here. Here P is at lower side and N is at higher potential. P is at lower potential, N is at higher potential. Diode D2 is off. This is off. Let's check this one. N is at plus 2 and P is at minus 4. P is at minus 4, N is at plus 2. So again this will also be off. So between minus 4 to 4, both diode will be off. Between minus 4 to plus 4, both diode will be off. You can check it, right? Between minus 4 to 4, both diode will be off. Both D1 and D2 are off. So I guess I will just copy this circuit and just paste it there. Okay, now both are off. Both are off. So what will happen? This is zero potential. There is no meaning of these potentials. No meaning of these potential. Complete. If this is also off, this is also off. That means there will be no current through the resistor. So complete V out, V in will be going towards the V out. This is 0, this potential will be V in, this potential will also be V in, this potential will also be V in, and V out will simply be equals to V in. V out is simply equals to V in. So what did you see here? I guess I can write it in short. So in conclusion, what did we see? First, for V in greater than 4 volt, what was our output? Output was 4 volt only. For V in greater than equals to 4 volt, output was 4 volt only. Second, for V in less than equals to minus 4 volt, what was our output? Output was minus 4 volt only. For V in less than equals to minus 4 volt, output was minus 4 volt only. Third thing, when V in is between 4 volt, minus 4 volt to 4 volt. When V in is between minus 4 volt to 4 volt. At that time, V out will be equals to V in only. So what are the two transition points? 4 and minus 4. 4 volt and minus 4 volt. Right? So for V in greater than 4 volt, V out is equals to 4 volt. For V in greater than 4 volt, V out is equals to 4 volt. And for V in less than minus 4 volt, V out is equals to minus 4 volt. Right? And in between, V out is equals to V in. So this is how the graph will go. Now there are two transition point, right? Okay, so this will be 4 volt, this will be minus 4 volt. So there are two transition points. So this is the voltage transfer characteristics with the maximum value being plus 4 volt and minimum value being minus 4 volt. Well and good, very easy question. In the exam, what you will do? In the exam, by seeing this circuit only, you will understand what will happen. Okay, you will see that here minus 4 is there. That means if V in is greater than minus 4 volt, diode D1 will be off. If diode D1 will be, so if diode D1 will be off, and when V in is, okay, so this is not our transition point actually. So when V in is less than minus 4 volt, our first target will be to turn on the diode. Whenever you see this kind of clipper circuit, our first target will always be to turn on the diode. So I will try to turn on the diode D1. So what I will do? I will apply V in should be less than minus 4 volt. So diode D1 will be on. So for V in less than minus 4 volt. So for that condition, I will check the condition of D2 as well. So at that time, I say that D2 is off. So my simply output will be minus 4 volt. Then I will check for diode D2 to turn on. For diode D2 to turn on, V in should be greater than 4 volt. So that means diode D2 will be on and D1 will be off. So output will be equals to 4 volt. And then in between, what will happen? Both diode will be off. So output will simply be equals to V in. So that will be my transfer characteristics, and that will be maximum and minimum voltage. Let's move on to this question. Okay, in this question, the input was also given. The input was varying from minus 10 to 10 volt. This was our input, right? Sinusoid input was there. So sinusoid input varies from plus 10 to minus 10, or you can say minus 10 to plus 10, right? Actually, you can draw it, you can draw the final output with respect to sinusoid as well. Will you be able to draw, or I should draw it? What I mean to say, okay, let's draw it now. I will just copy one of the sinusoids. This I will copy. Okay, let me pause it. Yeah, so this is our given sinusoid. So what are our two transition points? That are plus 4 and minus 4, right? Plus 4 and minus 4. So for every value above plus 4, output is plus 4 only, and for every value below minus 4, output is minus 4 only, right? and in between it will follow the input. Just drawing the graph, nothing else. Yeah, so in between it will follow the input, and for above 4 volt it will be 4 volt only, right? It will be 4 volt only. Then again it will follow the input till this point, then it will be equals to minus 4 volt only. Then again it will follow the input, then it will be plus 4 only. Then again between minus to 4 to 4 it will follow the input, then it will be minus 4 only. Then again between minus 4 to 4 it will follow the input, and then again it will be follow the input, and again it will be plus 4 only. So that's how the graph will go. Okay, that's how the graph will go. Well and good. Let's move on to this question. This is a very good question. Okay, so you have to draw the voltage transfer characteristics, and you have to find the maximum and minimum value of V naught. Okay, so do it on your own first. Take your time, do it on your own, then we will check the solution. Okay, okay, so let's solve this problem. Okay, so what I will do, I will just copy this circuit on the next page, because we will be applying the open circuit test now. Okay, so we will apply the open circuit test. So here I have open circuited the diode D1 and D2. This side is N, this side is P, this side is P, this side is N. That I have written there. Okay, so this was our D2 and this was our D1. Well and good. Let's try to turn on the D1 diode first. Okay, you can turn on any diode. Let's try to turn on the diode D2 first. We will try to turn on the diode D2 first. So what will happen here? If this potential is 0, if both diodes are open circuited, that means there will be no current through the resistor. There will be no current through this resistor as well. No current through any resistor. So if this is 0, this will be V in. This will also be V in, right? So let's try to turn on the diode D2 first. So when V in is greater than equals to 4 volt, at that time diode D2 will be on, right? What will happen to diode D1? V in is at 4 volt, and N side is at 4 volt and P side is at minus 4 volt. Pn is at 4 volt, P is at minus 4 volt. That means diode D2 will be off. Diode D2 will be off. And if diode D1 is on, that means simply V out will be equals to 4 volt only, right? Because diode D1 will be off. Diode D1 will be off. If it is on, then simply V out will be equals to 4 volt. Okay, let's check for the condition when. Now let's try to turn on this diode D1. Okay, so what will happen? At N side you are having V in, at P side you are having minus 4 volt. At N side you are having V in, at P side you are having minus 4 volt. So what will happen? V in should be less than equals to minus 4 volt, right? The N side should be lesser than the P side potential. That means diode D1 will be on and diode D2 will be off, right? Because try doing it. If V in is less than minus 4 volt, if V in is less than minus 4 volt, that means P is at negative potential. So diode D2 will simply be off. So if diode D1 is off, if diode D1 is on, tell me what will be the output voltage. It will be minus 4. No, let's check it. This is resistance R. Diode D1 is on. Diode D1 will be simply short circuited. Then this 4 volt battery will be there, and this resistance R will be there. This V in will be there. This D2 will be off. That means it will be open circuited, and this 4 volt will be there. So there will be no use of this branch, right? There will be no current in this branch, no current in this branch. So there is no use of this branch. I can simply write V naught here. Now I need to find the value of V naught. V naught will not be minus 4 volt, because there will be some drop across this resistance R as well, because there will be current now, because there is this closed circuit R4 and R and this V in battery. So there is this closed circuit now. So there will be some current flowing through this resistance R as well. So V naught will not be minus 4. So what it will be? This potential will be V naught. So you can apply simple KCL. That will be V in minus, so V naught minus V in by R plus V naught plus 4 by R equals to 0. This potential is 0, this potential is 4. V naught plus, this potential is 0, this potential is V naught. V naught plus 4 by R. Current in this direction and then current in this direction. Outward current we are writing. V naught minus V in by R. Right? V naught plus 4 by R plus V naught minus V in by R. So V naught value will be V in minus 4 by 2. So that will be our V naught value. Okay, so that was the important point here. That was the most important point. Okay, let's check the third one. When V in is between minus 4 to 4. V in is between minus 4 to 4. At that time, what will happen? Both diode D1 and D2 will be off. You can check as well. Take an example, take 2 volt. P is at 2 volt, N is at 4 volt. D2 is off. N is at 2 volt, P is at minus 4 volt. D1 is off. Both diode D1 and D2 will be off. If both are off, that means V out will simply be equals to V in. Right? So now we can make the graph. Okay, or in conclusion, we can write all the points. When V in is greater than 4 volt, or V out was, when V in is greater than 4 volt, V out is plus 4 volt. Secondly, when V in is less than minus 4 volt, V out is V in minus 4 by 2. And third, when V in is in between both of them, at that time V out will be equals to V in only. Okay, now you have to draw the voltage transfer characteristics, and then you need to tell the maximum minimum values. What are our two transition points? That are 4 volt and minus 4 volt. So for V in greater than 4 volt, V out is 4 volt. V in greater than 4 volt, V out is 4 volt. That's 4 volt. Now for V in, for in between minus 4 to 4, V out is equals to V in. So this is how V out will look like. V out will be equals to V in between, right? In between it will look like this. V out will be equals to V in. And when it is less than minus 4 volt, this region, this was region 1, this was region 3rd. Now we are talking about region 2. So the slope is 1 by 2 now. Here the slope is 1. Slope is 1. Now you need to make slope 1 by 2. So let's assume if we increase this graph, this graph would have gone like this for slope 1. But the slope should be 1 by 2 now. That means it should be near to x-axis. Look, what is the slope of this graph? Let's assume the slope of this graph is tan theta. No, the slope of this graph is 2. Then the slope of this graph will be 3. Slope of this graph will be more than that, 4. And slope of this will be infinity, right? And slope of this will be 0. So if it is near to x-axis, the slope is less. So similarly, I need to make it near to the x-axis. So I will make somewhat like this. Slope is lesser here, right? So this graph represents V out equals to V in minus 4 by 2, right? Now I can remove it off. Yeah, so it is removed now. So this is my graph. V out is equals to V in. So this is how my transfer characteristic will look like. Now they asked you the maximum and minimum value. So maximum value you can see in this graph, that is 4 volt. What about the minimum one? Now the input value is varying from minus 10 to 10 only, right? Input is not going till infinity. Input is minus 10 to 10. So what will be the minimum value? Minimum value will be somewhere here. So minimum value will be V in of minimum minus 4 by 2. So V in of minimum, that would be minus 10. Minus 10 minus 4 by 2. So minus 14 by 2, that means minus 7 volt. So minimum value will be minus 7 volt and maximum value will be plus 4. So that was the beauty of this question. Okay. Here that resistance R came in action. So if you solve quickly, you will be ticking on minus 4. So that would be wrong. So minimum value is minus 7, not minus 4. Because when V in was less than minus 4, output voltage was not minus 4. Output voltage was V in minus 4 by 2. V in minus 4 by 2. Okay. So I hope you understood the complete concept. You understood the concept of everything. Clipper circuit, shunt clipper, series clipper, two level clipper. In the next video, we will see very interesting questions. The assignment will be very, very interesting. Don't miss out that assignment. Okay. Very interesting assignment that will be there. Okay. So if you found the video helpful, try sharing it with your friends. Thank you.